Hey guys, today we're doing Module 14, Lesson 3. We're going to represent addition of fractions. So you should be on page 371 in your math workbook. 371. I'll blow this up. Alright, so today's objective is to use visual representations to add fractions. I can write equations to model a given number or word problem. So let's look at our scenario. Caleb enters a frog in a frog jumping contest. His frog jumps twice. So twice means 2 times. Caleb wants to find the total distance his frog jumps. So it says explain how you can determine the lengths of each of the frog's 2 jumps, then find the total distance the frog jumped. Alright, so we can see right here on the chart, we go from 0 to 1 foot, and it is divided into 1, 2, 3, 4 sections. I'm going to clean that up. So we have 4 sections, and we know it's counting by fourths. So if there's 4 equal lengths, then we know we're counting by fourths. So I'm going to write 1/4 here, 1/4, 2/4, 3/4, and 1 whole is the same as 4/4, right? So 4/4 is the same as 1 whole. Well, the frog's first jump, his first one goes to 1/4. So he lands at 1/4. So his first jump is 1/4, and then he jumps the second time, and he jumps to 3/4. So they want to know the total distance his frog jumps. Well, in the first jump, he goes to 1/4, and the second one, he goes 2/4 plus 3/4. So he goes another 2/4. So he went another 2/4. So he jumps 3/4. And we can see right here, he jumped to 3/4 because he did it 1/4 and another 1/4. So he did 2 more fourths. So the total was 3/4. He jumps 3/4 feet. Okay, on the next page. Doing grasshoppers. All right, number 1, a grasshopper jumps 6 yards and then immediately jumps another 6 yards. How far does the grasshopper jump? Represent the jumps on the number line. Well, we want to do the same number of sections as we have as our denominator. So we're doing 3 6 and 2 6. So we should split our number line up into 6 sections. To get 6 sections from 0 to 1, we're going to put 5 lines. If we put 5 lines in between 0 and 1, we'll have 6 sections. Let's do, that's about 1, 2, 3, 4. Oh, that's bad. A little bit closer together. 1, 2, 3, 4, 5. That one up right there. 1, 2, 3, 4, 5. So this would be 1 6. This would be 2 6, 3 6, 4 6, 5 6. And you know that 1 whole is the same as 6 6. So we put 5 lines, 5 little tick marks, and we can make it 6 sections. So A says, what addition equation can you write to model the distance the grasshopper jumps? Well, the grasshopper jumps 2 6 yards. We start at 0 and he jumps 2 6 yards and then immediately jumps another 3 6 yards. So 1, 2, 3. So he's going to do 1 6, 2 6, 3 6. So here's where he lands. So if we're going to do equation, we would say he starts at 2 6 plus 3 6 equals to 5 6. 2 6 plus 3 6 equals to 5 6. How does your equation relate to what you drew on the number line? Well, we drew on the number line the first jump represents the first add-in of 2 6, and then the second jump is the sum of it. So it says each jump represents an add-in. Each jump represents an add-in. fraction, like 2/3. I'm not 2/3, 2/3, 2/6. 2, 6, and 3, 6. Those are my add-ins. So each jump represents an add-in, and the second jump is the sum. And the second jump is the sum. So the second jump right here, so jump 1, jump 2, the second jump is the sum. That's supposed to jump. Woo. J-U jump is, the second jump is the sum of our add-ins. I really messed this up today. 3, 6. Those are our add-ins. 2, 6, and 3, 6 are our add-ins. All right. C, the grasshopper jumps a total of 5, 6 yards. 5, 6 yards. D, what do you notice about the numerators? The numerators are our top number, 2 and 3. What do you notice about the numerators of the add-ins and the numerator and the denominator of the sum? So the sum of the numerators equals to the numerator of the sum. The sum of our numerators, that would be sum of numerators, so 2 and 3 equal to the sum of our add-ins. So 2 and 3 equals to 5, and that is the sum of our add-ins. 2, 6 plus 3, 6. The denominator doesn't change. Denominator, I'm going to abbreviate. Denominator doesn't change. We do not change it when we have like denominators. Really easy to add fractions when the denominator is the same. Turn the page. All right, now we have a rabbit. Sam's pet rabbit lives in a hutch with a sleeping space that has an area of 3/12 square yards. So a hutch would be like a wooden, like a big wooden type box, okay? So think of a big rectangular box. All right, so Sam's pet has an area of 3/12 square yards. So Sam's 3/12 square yards. But Cece's pet rabbit has a sleeping space that has an area that is so let's do Cece. Cece's is 4/12 square larger. 4/12 larger. So larger means bigger. So Cece's pet is not 4/12 square yards, is 4/12 more than the 3/12. So on top of. Use the fraction model to find the area of Cece's rabbit's sleeping space. Shade the fraction strips that represent the area of the sleeping space for Sam's rabbit. So Sam's rabbit has 3/12 sleeping space. Use a different color to shade how much bigger the area of Cece's sleeping rabbit is. So we want to find out how big Cece's rabbit space is. So how big, what is the area of Cece's rabbit space? So let's do Sam. Sam's had 3/12, so 1, 2, 3, we did it in green, and then we want to add to what Cece's rabbit. So her rabbit space is 4/12 square larger, so that much more. So 1/12, 2/12, 3/12, 4/12. Write an addition equation to model the area of Cece's rabbit space S. So we will say 3/12 plus 4/12 larger plus 4/12 equals to S. That's the area of Cece's rabbit sleeping space. So let's solve for S. So S equals to 3/12 plus 4/12. So we add the numerator. 3 plus 4 is 7. 7, and we keep the denominator the same. 7/12. So it's 7/12 square yard. So this question could have been hard if you didn't realize that the 4/12 larger means that Cece's space was not just 4/12, it was 4/12 bigger than the 3/12. So I want you to try number 1, 2, and 3 at the bottom of the page. So pause the video now, attempt 1, 2, and 3, and then start the video back to check yourself. All right, in question number 1, it says use the number line to find the sum. So we have 4/10 plus 4/10. Let me count this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's counted correctly. So we have 10 sections. So if we're going to jump from 0 to 4/10, so let's go ahead and label. That's 1/10, 2/10, 3/10, 4/10. 5/10, 6/10, 7/10, 8/10, and you might not have labeled yours, that's fine, as long as you just don't make a mistake counting them. So we're going to start at 0 and jump 4/10. So, and then we're going to do another 4/10. So 1, 2, 3, 4, we're going to end right here. Another 4/10. 4/10 plus 4/10 equals to 8/10. Number 2, 1/4 plus 1/4. We add the numerators. 1 plus 1 is 2. The denominator stays the same. It is 4. And number 3, we add the numerators. 1 plus 2 is 3. The denominator stays the same. It's 8. We have 3/8. And that is it.